everyone. So today we're continuing our conversation about sequences, okay? Yesterday we talked about sequences and how explicit formulas work for sequences. Today we're talking about what's called a recursive formula for a sequence. So the sequences haven't changed, just the formula for generating the sequence has. So a recursive formula is a formula that relates each term in a sequence to the previous term. If you remember, that's a little different than yesterday when we did explicit formulas. Explicit formulas relate each term in the sequence to the term number. Now we're talking about relating back to the previous term. I'm going to illustrate that with this sequence that's given to you down here. So really when I'm talking about the sequence, I'm talking about this bottom row. This is 2, 5, 8, 11. This is my sequence. This is just my term number up here. Okay, so term 1, term 2, term 3, and so on. Okay. An explicit formula says, I want to take this 1 and turn it into a 2. And I want to take this 2 and turn it into a 5. And I want to take this 3 and turn it into an 8. That's an explicit formula, okay? Where we're relating terms this way, almost like a function, right? Where term 1 is this, term 2 is this, and so on. That's explicit, okay? And in our case, and again, you don't have to necessarily know where this came from, but let's see, I believe this sequence is going to be t sub n equals, let's see, is it 3? Yeah, 3x or 3n minus 1. And again, you don't have to know where that came from, okay? We haven't talked about how to get that yet. But if you take a look at this, if you do 3 times 1 and then subtract 1, you get 2. 3 times 2 and subtract 1, get 5. 3 times 3 and subtract 1, you get 8. 3 times 6 and subtract 1, you get 17. Okay, so that's my explicit formula. Okay, what we're talking about today then is called a recursive formula. And the recursive formula is when you look at it this way. Oops. When you say, oh, from here to here, I add 3. And from here to here, I add 3. And from here to here, I add 3. Okay? That is what's called a recursive formula. Okay? So it has nothing to do with the term number. It has to do with how do you get from one term to the next? How do you kind of leapfrog from one term to the other? Okay? So let's talk notation here. Because I think that recursive formulas, people tend to get bogged down just in the notation. With a recursive formula, you always have to do 2 things. You have to identify the first term. So I'm just going to do this one up here. I would say term 1 is 2. Okay? Because if you're all about jumping from one term to the next, you have to know where to start. Okay? And then I'm going to say any other term in the sequence, which you'll recognize that is the same as what we used up here, is found by taking the previous term, and that's going to be really important here, that this t sub n minus 1 represents the previous term, and adding 3 to it. And I'm just going to make a quick note here that this is really just notation for previous term. Do not get bogged down in the n minus 1. Do not get worried about the math involved there, okay? You're not doing any math there. You're not actually subtracting 1 from anything. This is just meant to reference that if we're looking at term 5, this would be term 4. Okay, if we're looking at term 20, this would be term 19. Okay? So I kind of already said this, but a recursive formula must define the first term. So that's where we say T1. And then a rule for generating all the subsequent terms. That would be something like Tn equals previous term, blah, blah, blah. So maybe we're adding something every time, or maybe we're multiplying by something every time, or so on. Okay? So you have to have these 2 pieces, and usually we put them in a bracket like this. Okay? That's a recursive formula. Okay, so let's take a look at this first example and see how we do with this notation. Okay, example 1. And it says, just explain what's happening in words here. So let's start with this, that T1 equals 26. What is that telling us? That's telling us to start at 26. And then to generate all the other terms, we're going to take the term before and subtract 5. Okay, so I'm going to show you really what's happening with this sequence, and then I'm also going to show it to you in notation down here. But this is basically saying my sequence is going to look like this: 26 and subtract 5, so that'd be 21. And then subtract 5, and that's 16. And then subtract 5, and that's 11, and so on and so on and so on. Okay, that's all this notation is saying. Start at 26, and then subtract 5 every time. Okay. By the way, and I should have mentioned this even back here, this number that you're adding or subtracting every time is what's referred to as the constant difference. Okay, that becomes more important, I think, later when we talk about a particular type of sequence. But if you hear me refer to the constant difference, that's that number right there. Okay, so I kind of already did this last thing, right? The listing the first 5 terms, but I just wanted to write it out kind of in notation. So term 1 is 26. Term 2 is saying to do 26 minus 5. That's the previous term, and I get 21. Term 3, I'm going to take that 21 and subtract 5, and I get 16. Term 4, okay, oh, and you can't follow me because you can't see what I'm doing. Sorry about that. Okay, term 4, I'm going to take 16 and subtract 5, and I get 11. So just in case you weren't seeing where I was coming up with these, this is the actual math behind it. And that t sub n minus 1, gosh, I keep pointing to things you can't see. That t sub n minus 1, this thing here, is really just doing this for us. It's really just saying plug in the previous term. Okay, I guess we should get term 5 here. So term 5, I'm going to take that 11 and subtract 5, and I get 6. Okay, so here's your sequence: 26, 21, 16, 11, and 6. Okay, so that's a pretty straightforward recursive formula, and that's what a lot of them are going to look like for you. I want to take a look at this next example, though, because it's not as straightforward, and I do believe there is one on your homework assignment that's similar to this. Okay, so this is saying term 1 is 1, and then to get the next term, I'm going to take the previous term and add n. Remember, n is referring to the term number. Okay, so here's what this sequence is going to look like. Term 1 we said was 1. Okay, to get term 2, I'm going to take that 1 and add on the n value for that term, which is in this case 2, and I get 3. Okay, to get term 3, I'm going to take my previous term of 3 and add my term number, which is also 3, and I get 6. Term 4 would be previous term of 6 plus my term number of n, which is 4, and I get 10. Term 5 would be my previous term of 10 and add my n value to get 15. Okay, so my sequence would be 1, 3, 6, 10, and 15. I just wanted you to see that one written out because, again, I think there is one on your homework assignment that's similar to that. I think I'm going to leave the Fibonacci sequence alone right now. The Fibonacci sequence is a very fascinating sequence. It has a lot of applications mathematically. Basically what happens here is you start with 1 and 1, and then you add these two together to get the next term. And then you add these two together to get the next term. And then you add these two together to get the next term. Okay, so you're always adding the previous two terms together. This sequence is generated recursively, meaning that you always have to have the previous terms to be able to get to the next one. I'm not going to stress so much about writing the rule for it and all of that. That's sort of just a enrichment type thing, but this one is in your textbook if you're curious about it, if you want to take a look at it. Okay. I think that's it for today. So you can go ahead and jump into the lesson masters for homework tonight, 1-7 and 1-9. 1-7 will be a review of what we did in class yesterday, and then 1-9 covers this material. So if you want it to be fresh in your mind, you may want to start with 1-9. Okay? Have a good one.